See, good afternoon to you all here. Hope you guys are doing well. Anyway, this is what, 517, is that true? So let's look at this. All right, so I'm going to mention something here to you guys. I won't do it right now, but let me go through what we're doing today. We're going to do a little bit of some S, ladies and gentlemen. You might say, what is S? Some supplement information. This is going to be something that we use today. I want to see if you guys understand the meaning of less than. What do you guys think? We got to go back to understand that meaning to use what we're going to do today. So what I have here is we're comparing numbers. And you got this A less than B. How do you guys want to think of this? You guys ever learned this before in your life by any chance? What do you think? You guys ever see this before? A less than B? Maybe. I think we do have some language here for you guys on that summary sheet. But remember, what is JAWS open to? JAWS always opens to the bigger number. Is that true? All right, so this is a phrase reading left to right. A is less than B. Now, we're going to compare decimals now, right? We're going to look at some decimals, and we're going to try to see, in comparison, which is less than, which is greater than. We're going to see if it satisfies this inequality here, okay? Now, for some people, decimals are a big mystery. You guys know what I'm talking about? Are decimals a big mystery? I would say to you, if you've ever looked at, if you guys notice, the place value for these decimals are the nearest hundredths. If you ever looked at your receipt, if you ever went shopping, and everybody has, hopefully. If you've ever been shopping, haven't you looked at the receipt? Do you guys see decimals? Okay, think of money. So if I said to you, if you've seen 0.11, what does that stand for with money? Does that stand for 11 cents? All right, what about over here? What does that stand for? 0.23. If you looked at your receipt and it had 0.23, you would say that's what? 23 cents? Is that true? Okay, let's ask you guys this question then. Is it true that 11 cents is, what's the phrase here? Less than 23 cents? Is that true? Is JAWS opening to the bigger dollar amount or the bigger change? That's a true statement. So we leave the inequality there. So that's true. You guys okay with that? We're doing some S this morning or this afternoon, supplementary material. Now, look at the next situation. What are we looking at here? What does this say? Is 56 cents, isn't that what 56.56 is? Is that less than 18 cents? What would you guys say? Yeah, it's not. In other words, I'm going to do this here, right? I'm going to cross that out. What does that stand for? Not what? Less than. So that's a false statement. Are you guys okay with that one? So this is not less than. What do you guys think? Is that pretty good? We're going to need this information today. You're going to be happy you guys showed up today. All right, what about this next one? What are you guys looking at here? Is 99 cents less than 92 cents? No, so cross it out. That's saying not what? Not less than. That's a false statement, okay? What do you guys see here? Is $1, is it $1 on the left if it was 1.00? And then what's 0.01? Is that 1 penny? Is $1 less than a penny? No. What do you guys do? Cross it out. This is not what? Not less than. Good. Okay. Now, what if you see, you probably aren't going to see this in a receipt. Are you going to see 0.00? No. That's like, I hope your checking account balance is not zero zero because that means you're what? That means you're broke. Is that true? Don't worry. It could be worse. Could be negative. So is 00 less than a penny? Yes, that's a true statement. You guys okay with that? So that's true. This is false. Is everybody okay with what we just did? You guys know what I mean? Anybody have any questions on that? Is that easy or is that hard? It's important for today. So you guys are in for a little treat today. So I'm going to test you guys on this idea here. I want you to double check and find where it's true, find where it's false. Because the key phrase today is less than. I'm going to give you guys some time to do this. I'm going to give you guys less than 5 minutes to do it. See what you guys get. All right, ladies and gentlemen, let's double check here. Okay. So is 88 cents less than 22 cents? Say what? No, it's not less than. That was a false statement. Is that right? Okay, you guys okay with this? Is being broke less than having a dollar? Yeah, that's a true statement, ladies and gentlemen. Good. Okay, what about 65 cents? Is that less than 8 cents? No, that's not less than. Is that true? Is 21 cents less than 11 cents? No. Is 1 penny less than 5 cents? Yes, this is true. So this is true. False, false. What do you guys think? Is that okay? Is that easy peasy lemon squeezy? All right. Anybody have any questions on this? Because we're going to use this today. It's the basis of what we're going to use today. All right, ladies and gentlemen. Okay. So what I'm going to introduce to you guys today is this. We have hypothesis testing again by what is called the modern method, and that's the p-value method. Has anybody ever heard this before? Do you guys know what I'm talking about? You might have heard it before. So the reason I have to talk about it is because you might be taking some courses in your life somewhere, someday, where you're going to have the p-value method, the modern method, and you want to be able to participate in your discussion in your lectures. Is that right? You want to be knowledgeable. So, all right, let's kind of begin with this so you guys can see. Now, of course, here's the thing about what happens, unfortunately, right? As you start to use more and more technology, sometimes the essence of what you're doing gets lost. So the more technology you use, the essence of things gets lost. It's a double-edged sword. Okay, it's a real double-edged sword, and that's kind of the problem. So you're going to have to kind of bear with me with some of this stuff here, and I'm going to kind of read to you what notes I wrote down about this, because I want you guys to be educated with this idea. You see, here's what's going on with hypothesis testing. Now that you guys have had some experience with it, you guys have experience with what's called the traditional method. You know, where you have your decision rule, you have critical values, and, you know, it's based on what's called the traditional method. And you got to go through those steps. And historically, you had Z tables, and we had a lot of information there that we have moved forward on as we've modernized our approach, not always to our benefit, however. Okay, so anyway, it's philosophical. But here's what I want to say. Our entire analysis can be boiled down to one number called the p-value. So remember what you're doing here. You're testing a hypothesis. And what they're saying is, going out and taking a sample now, we're not going to compute a test statistic and see where that test statistic lives. We're going to compute a p-value. It's really based on the test statistic, but that's a whole other story. And we want to find if that value is less than the level of significance. Excuse me. Now, remember, your level of significance is alpha. So we're going to try to see if that p-value that we're going to compute is what? Less than the level of significance. That's going to be the basis of the modern approach. Okay? Now, what happens is this. If the p-value is less than alpha, you want to know what we can do? Then we what? Automatically accept the null hypothesis. This is the modern method. This is why we warmed up today doing a little S support by looking at some mathematics, the less than sign, and really comparing decimals. Because P, there's no coincidence why we call it P. Okay? Because this is really all based on probability. This is not based on certainty. Hypothesis testing is based on likelihood, probability. Small probability values, remember that? Large probability values, okay. So on a technical note, let's talk about some technicalities here, right? The alternate hypothesis may or may not be your claim. I'm just saying. We're talking about H naught here. We're not talking about the claim, so don't even think about the claim. Just get it out of your head. Just think about H naught, H1, alternate hypothesis. Think about those things. The alternate hypothesis, H1, may or may not be the claim. That's kind of what I'm pointing out to you. So that means our conclusions are still going to be one of the following statements. We're still going to have this as a conclusion. Either the sample is going to support the claim or the sample is not going to support the claim. Those are our conclusions. But those conclusions are all indirect. They're based on the test. So we have to go with what the test is saying to us. Now let's read that. It all depends on the what? On your p-value. Okay? And the level of significance and where your claim happens to be, a null or alternate hypothesis. Okay. So let's focus on the p-value and say this. The p-value, ladies and gentlemen, is a probability value. That's why they call it p. It's the probability of obtaining that particular test statistic. That's what that is. Right? It's a probability of getting that test statistic value. Assuming, here's the assumption. It assumes that the null hypothesis is what? Correct. That's what the p-value is. The p-value assumes the null hypothesis is correct. So let's say the p-value is close to 0. That's the probability of getting the test statistic assuming the null hypothesis is correct. So if it's a small probability, you have an issue with that, okay? The level of significance alpha is really a threshold value. It's a borderline chance of making a statistical decision. So alpha is all of these values. Alpha is just a threshold value. It's a borderline chance here, right? So in summary, we are willing to take a alpha % chance of rejecting the null hypothesis when it is actually true here, okay? So we are assuming the null is true. And this is essentially the background behind all of this, and we're going to see how to use it, okay? So we're going to see how to use that. And so these are the threshold values of alpha. That's the meaning of your level of significance. But again, the p-value is the probability of getting that test statistic, assuming the null hypothesis is true. Okay, so this is kind of what we're going to do now. So I want to remark technically on a technical situation, there's a possibility of errors, and there's two types of errors. When testing a hypothesis, we arrive at a conclusion of either rejecting it or failing to reject it, which means accept it. Our conclusions are sometimes correct, sometimes wrong, even when we follow our procedure correctly. In essence, a hypothesis test is based on the likelihood and is not certain. So we have something defined as a type 1 error. That's the mistake of rejecting the null hypothesis when it is actually true. So that's called a type 1 error. A type 2 error is the mistake of failing to reject, accepting the null when it's actually false, and that's beta. But you might take other courses and they'll talk about alpha and beta in more detail. So I just want to let you guys know that, yes, we've been going with the traditional approach, but in some classes they go with the modern method, and you might be taking those classes, they go with the p-value now. So I want to give you guys a little bit of experience with it, okay? Now, all of these examples I'm going to go through here with you guys, we already did by the traditional method. All of these examples that I have here. So you said, we did this already? Yes. So I want you guys to read, because this is important to do, right? We said the proportion of college students who are infected with COVID during the pandemic is 25%, okay? As claimed by who? Good old Snodgrass, okay? You guys okay with that? So the proportion is what parameter? That's P. The word is, we know, equals. Is that right? So the claim here is P equals 25%. And notice, isn't that what I put over here? Because it's a null hypothesis. So we actually did these already. It's in your notes. It's in the videos. We did it already. I just want you guys to verify this by the what? By the p-value method. So let's go through some of this. Yes, isn't that a two-tailed test? Not equal. What does that mean? Two tails? Then we have to create the decision rule. And you said, oh, Mr. Judge, you said we're not going to do that anymore. I know, but I'm going to share with you guys how this works. We had to use inverse norm to get the critical values. You guys remember that? Alpha is 5%, so 2.5 is in each tail. Okay. Now, we went through one proportion z-test. We got this piece of information when we did it. We entered the sample information. Here's your sample information again. We already did this question. It's in our notes. What I want you guys to know is, where is the p-value? The test statistic is right here. It's in purple. The p-value is where? Right next to it, or right under it. It's the third line. It says P. You say, what's the next one? Well, that's a sample proportion with a p hat, which is about 29.6%. Sample size was 1,200. The point I'm making is the p-value is right there in the middle. And I can't actually do this right. Oh my God, really? I can't actually do this because my highlighter's too what? Maybe I could do it like this. What do you guys think? Whatever. Let's write it down. Your p-value, ladies and gentlemen. What's that? Be careful here. What does that mean? It's not an error. Do you guys know what that means? You got to move your decimal where? How many spaces? 4 spaces. So this is like 2.5. Move 1, 2, 3, 4, and fill this in with how many zeros? 3 zeros. So if I approximate this to the nearest hundredths, your p-value is approximately, it's close to what? 0. You with me on that? That's scientific notation. You say, isn't it 0.00000 approximately? 3 zeros and 2? Well, that's now moved. This is the p-value, but it's approximately 0 here. Okay, you guys with me on that one? Now, what do we have to compare here? We want to know, is p less than alpha? What was alpha? Alpha's what again? Wasn't alpha 5%? Okay, this is the modern method. 5%. So you guys might see this in some classes. You take p-value and go, what in the world is that? Here we go. Is this a true statement? Here's your alpha. Here's your what? P-value. Is that true? Is 0.00, which is being broke, less than a nickel? Yes. What does that mean, ladies and gentlemen? Automatically accept what? The alternate what? Hypothesis. You guys okay with that? This is what I'm saying to you. If you have that satisfied, we automatically accept the alternate. So what is the alternate? I'm sorry. The proportion is not 25%. What's your conclusion, though? Because if you're accepting the alternate, you're rejecting the null. It's out. So what is our formal conclusion now? This is what we want to know. What's our conclusion? The sample does not support the claim. Is that right? You say, why does the sample not support the claim? What did you throw out? You threw out the claim. In fact, it suggests that the proportion is not 25%. Now, when you guys did this before with test statistics, in your notes, right, you got the test statistic to be about 3.67. Isn't that right? You're looking at it there, Z value, 3.67. So on the decision roll, 3.67 is where? It's over here somewhere. That's your test statistic, 3.67, right? What neighborhood is it on? You're rejecting the null. Isn't that what you just did right here? Didn't you just reject the null? So my point is, ladies and gentlemen, the p-value method is it's thought of as the modern method. It's a little bit of a shortcut from the traditional method. Now, that probability, if we said this, p-value is the probability of obtaining the test statistic, assuming the null hypothesis is correct. We just threw out the null hypothesis. Is that right? What was that p-value approximately? It was approximately 0. What does that mean? It's not likely. It's not likely for you to get the test statistic you got, assuming the null hypothesis is correct. I'm going to do that again. It's a pretty powerful thing. The p-value is the probability of getting that particular test statistic, assuming the null hypothesis is correct. So if that probability is close to 0, it's not likely to get that value, assuming the null hypothesis is correct, which means your null hypothesis is not correct. That's the meaning of this whole idea. But for us, all we got to do is what? Look at this comparison, and it tells us, do we accept the null or do we accept the alternate? And that's the end of the story. So the probability is close to 0 that you'd get that particular test statistic when the null hypothesis is correct. So you're accepting the alternate because that's a very low what? Probability. Remember, probability value is not likely. It's not likely that you're going to get that value, assuming the null hypothesis is correct. So that's the technical meaning of it. Anyway, so it's a shorter cut version. And I have it summarized here in the notes. So for you guys at home, let's do that here. I don't think I did that. So for people at home, and maybe some of you guys even here, I would say go to 227 and you go, Mr. Judge, I like your notes. Boy, I'm going to sell them to my cousin who's going to take the class one day, or give them to my sister. Let's find it. You go, oh, p-value, modern method. Okay, so as it loads, I'm going to give you guys the notes for this here, okay? It's online. Oh, man. So there's those notes. Okay, so you guys get to have a copy of that stuff. Do any of you guys print this up and look it over? No? I don't know. It's only going to save your life, but that's okay. Sample does not support this. We automatically accept the what? The alternate hypothesis, p-value and alpha. Let's look at the next example. Let's see this again. Let's see if you guys know what we're talking about here on this, okay? Did we do this here? Let's double check. The proportion of college students who have a Netflix account is what? Less than 75%, okay? As what? As claimed by who? Good old Snodgrass. All right. P for proportion. What is this here? Less than. Is that true? That's the claim. So P less than, what kind of hypothesis is that? You're actually looking at it. It's what? P less than 75%. You guys see how I wrote it down? What is that, ladies and gentlemen? Isn't that an alternate hypothesis? Didn't I write it down here? And that is our claim. You always want to put that there. That's why I even put it in red. Claim in red. All right. What's the logical opposite of less than? Greater than or equal. Good. What kind of tell test is this, since I'm looking at it? It's left. Isn't that pointing to the left? This is why I drew a picture of a what? Of a left tail test. Okay. Alpha is 1% in this question. So all of the alpha by the traditional method, all of that 1% is in your left tail here. And of course, we got the critical value using inverse norm. So we did this last time, ladies and gentlemen. Okay, it's in our notes. We did the traditional method. We're doing the modern method today. We're looking for what? The p-value. You say, what's my p-value, ladies and gentlemen? Oh my God, what is this p-value? The p-value is the third line. If this was money going to the nearest hundredths, 0.999, isn't that approximately 1? That's your p-value to the nearest hundredths. Okay, what do we have to check? Is the p-value less than the level of significance? What are we really checking? Is that 1 less than, what was alpha? Wasn't alpha 1%? Okay. Is that a true statement? Is $1 smaller than a penny? The answer is what? No. Okay. What do you do then? Do you accept the alternate? No. You know what you do then instead? You accept the null. So I want you guys to know that here, okay? So what is the null then? We're accepting what? We're accepting the null here. You guys okay with that? By accepting the null, we have to reject the alternate, which means we're rejecting the what? The claim. What's your conclusion then? The sample does not support the claim. You say why? Because we threw out the claim. The claim is out. The claim happens to be the proportion is less than 75 cents. So this is saying that the proportion is what? At least 75%, really. So at least 75% of college students have, Netflix. Now, what we did last time is we actually just computed a test statistic, which is 3.15. 3.15 on our decision rule, isn't that over here? Isn't that in the what neighborhood? Do not reject the null. That means accept the null, and that's exactly what we did. We accepted the null. So compare the traditional method computing a test statistic with the modern method, it's the same conclusion. Now remember, a probability value almost 1. This is approximately 1. That means it's approximately certain. Okay? That means it's, well, what's a probability close to 1 mean? You guys remember? The p-value is the probability of obtaining the test statistic, assuming the null hypothesis is correct. So it's almost certain we're going to get that value, assuming that null hypothesis is correct as a test statistic. Almost certain. That's what the p-value is, ladies and gentlemen. It's a probability. And this is what I summarized in the book. In case you guys ever want to buy the book, it's going to be at Barnes & Noble. You going to Barnes & Noble? Okay. Get my novel. All right? All these notes are going to be in a book. What do you guys think? How much should we charge? Well, based on the likes I get on the videos, I don't think I could charge very much. Let's try this one again here. Let's try. We already did this one as well. The proportion of college students who get a good night's sleep. How do we define a good night's sleep? 8 hours, at least 8 hours. Anybody get at least 8 hours? Oh, the night before a final? Is what? Let's do this here. The proportion P who get a good night's sleep is, what do they say? Is no more than 33%. What does no more than mean? That's less than or equal. Is that right? And that is the what again? Isn't that the claim? What kind of hypothesis is this? Isn't that a null hypothesis? Why is that a null hypothesis? Because of what? The condition of equality. What's the logical opposite to that? Greater than. Okay. What does that mean about our test? Isn't that a what? It's a right-tail test. Now, they're going to ask us to test a hypothesis by the p-value method. All right, we've got to compute the p-value, but what's the level of significance? 10%. It's the threshold value. All right. So when you punch this in the calculator, like you were doing, one proportion z-test, which number is the what? Which number is the p-value? It's the third line. What's the p-value approximately again? 1. If we go to the nearest what? Tenths. Almost certain to get this number. What's the criteria? You got to check. Is the p-value less than the level of significance? Well, the p-value was 1.00, and our level of significance was, what was alpha? 10%. Is that true? And 10% is 0.10. Is that statement valid? Is $1 smaller than what? 10 cents? No. What does that mean? I accept the null hypothesis. So if the p-value is not less than the level of significance, we accept the null. Remember, the p-value is a probability of getting the test statistic, assuming the null is correct. So the probability is 1. Well, it's close to 1. It's almost certain to get that. We're going to accept the null hypothesis. Accepting the null means the alternate is out. Is that true? So the formal conclusion is going to be what? Sample supports the claim. What do you guys think? Is that okay? So this is the stuff we've been working on. And in fact, we also worked on hypothesis. I summarize it here in our Barnes & Noble book. Could you imagine I get blessed? Then I get to Maui. And then I get all the residents in Hawaii telling me to go home. We don't want you here. Do you imagine that? I get so lucky to go to Maui, and then they tell me to go home. Anyway. All right. You might say, does this work for the mean hypothesis about a mean and large samples? I'll say yes, it does. The mean IQ scores of college professors is what? No more than 125. As claimed by who? Snodgrass. You. So what's the no more than? What does that mean? It's less than or equal to 125. Isn't that the claim? Did we put it in the right spot? Let's put it all there together. What do you guys think? That's a null because it has a condition of equality. Here's the alternate. You might say, Mr. Judge, can I use the modern method for this too? Yes, you can. Well, we're going to have to use the 1% level of significance, though. So, again, we already did all of these last time. 1% is going to be 0.01. Okay, there's your alpha. So we did this by the traditional method last time. We entered the sample information here. And then notice this here, okay? Line number 3 again, because we're going to have to check, okay? Getting the p-value is the same as what we did last time. The probability value, here they say equals 1. That means it's certain. It's actually approximate, but what happens is there's not enough zeros here to say that. So this is certain. The probability of getting this particular test statistic is certain, assuming the null hypothesis is true. So you're saying, what's the chance that I get that test statistic value? It's certain to get that. So when you look at the criteria and you say, well, I guess I'll put it down here, okay? Is the p-value smaller than the level of significance? Well, the p-value is 1. Is that smaller than the 1%? The answer is no. So if it's not equal, we automatically accept the what? The null hypothesis. You accept the null hypothesis and you say, accept, well, what's the null? Well, the null is right here. That means you're rejecting the alternate. So the chance you get this particular test statistic is certain when you assume the null hypothesis is true. So it's certain to be that value. What does that mean about the claim? Sample supports the claim. Now, I didn't say this, but notice, isn't that a right tail test again? Because inequality is pointing to the right. You always look at the alternate hypothesis that tells you that. So anyway, these are all the details we're going to end up using, but these are all the details we used last time. Every one of these things we used last time. These are examples. And then there's my summary. P is 1, which is not smaller than 1%. We do not accept the alternate. We accept the null. Sample supports the claim. Okay. The mean lifespan of California residents is 77. Here's mean is 77.8 years. As what? Claimed by the state of California. So this is mu what? Equals what? That's your claim. Did I put it in the right position? I did. Is that true? Because isn't that short for is equal to? So it's a null hypothesis. The opposite is not equal. What do I look at to see that this is a two-tailed test? I look at what? The inequality in the alternate hypothesis, two tails. Isn't that what we did last time by the traditional method? Now, when you enter everything in, you're going to get the p-value to be what? P-value is approximately to the nearest hundredths 0.07. Okay? So the level of significance was 1%. We forgot to notate that. So if I wanted to, let's do it up here, right? Let me say, is that p-value less than alpha? Well, what do you guys know about that inequality? Is 7 cents smaller than a penny? Say what? No. What does that mean? You accept the null. And you're rejecting the alternate. So in conclusion, the sample what? sample supporting the claim. Okay, because the claim happens to be the null. Okay, so there's our notes there. Let's try one more. You guys ready to try one more? Here we go. Did you guys start to get a good feel for the p-value method? Okay, because we're going to try it out. So it says what? The mean number of units college students take in a remote learning environment, what does that say? Is not, how do we represent is not? Is not equal to what? 12. As claimed by campus researchers. So when I write this down, here's our mean. Mu is not equal to 12. Isn't that the claim? Did I put it in the right position? Because it does not, right? Isn't that an alternate hypothesis? You guys with me on that one? And moreover, not equal. Isn't that a two-tail test? By the traditional method? All right. Alpha here is what? 10%. What do you guys think? Not too bad? Okay. So by the traditional method, yes, you would get critical values again by using inverse norm. Now, though, I'm going to say this. Let's get the p-value. If you put in all the sample information, you go, oh, look at this. This is even more insane. Look at this p-value. Do you guys know what e to the minus 34 is? Woo-hoo. That is very much close to 0. Your p-value is approximately what? 0. So it's approximately 0. It's like, remember what probability equal to 0 is? It's impossible. So it's like saying it's impossible to get this test statistic value of negative 12.2 when the null hypothesis is true. It's impossible to get that number. So that's going to give you a pretty big hint because you're going to compare, is that p-value less than the level of significance? Well, is 0 less than 10%? The answer is what? Yes. That means you automatically accept the alternate. So for accepting the alternate, we're rejecting the null. So the chance you're going to get the test statistic you got when the null hypothesis is true, there's no chance that that's going to happen. So then now we say the what? Sample supports the claim. So appreciate the context of what I'm doing. We did all of these examples before by the traditional method. And you know, the traditional method says your test statistic is negative 12.2. Boy, the traditional method, it was way out here. It's really further away. And by the traditional method is to the left of your critical value. You're in the reject the null region, and that's exactly what we did. We rejected the null by the traditional method. Okay, you guys okay with that? All right, now, this is the p-value method based on all the work we did last time. So I'm giving you guys the modern method, okay, because it's You might see it in courses you guys take. They talk about p-value, the modern method, and now you can say, okay, I think I've seen something like that, but we're going to see more of it in new tests. So I'm going to give you guys a quick break. You guys like some breaks? What are you guys doing break? You eat? Okay, well, go eat. I'll see you guys in a few minutes, and we will continue with the modern method. Okay, ladies and gentlemen, we are back. What I want you guys to do now, let me go back here. Actually, yeah, if you are home online, I want you guys to go back here to, yeah. So what we're going to look at on the online transition for the notes, the novel I'm going to write, hypothesis testing about a mean small sample. And hopefully that will come down in a few seconds. There we go. So this is related to estimation about a mean and small sample as well. So let's find it. Let's find where we're at. Okay. How you doing, Blanca? I didn't see you there. Good afternoon. So these are the notes that I made for you guys here. I've also loaded them up on, whatever this is, the notepad. But what I want to do first is give you some information that's going to be important here for us. All right, so where are we at? Okay. Okay, hypothesis testing about a mean. Remember, what does mu stand for? Isn't that going to be a what? A mean. And we're going to also have what? A small sample. What's a small sample? Do you guys remember? Yeah, a sample size that's no more than 30. Ooh, look at the language I use. No more than. So very consistent. So just like estimation, if you guys recalled, with estimation, right? With estimation, you had to use the t-distribution. All right, you guys okay with that? This was the t-distribution. Now, the t-distribution approximates the z-distribution for small samples. Okay? Do you guys remember that? That kind of thing? All right. Now, here's the thing about this. Because we're looking at the t-distribution, we're going to look at the traditional method. And for the traditional method, to get your critical values, you're not going to use inverse t. You're going to use inverse, you're not going to inverse inverse norm. You use inverse what? T. So in the TI, I'm going to share with you guys a few things here. To get those critical values by the traditional method, you're going to have to use what? Inverse t. Inverse t. Okay? So this is under the critical value situation. Also, they give you guys a definition of what they call the degree of freedom. Bless you. Bless you. And that is actually one less than the sample size. Okay, like I said, when you start to rely on all this technology, all these little details get really watered down to some degree. So I just want to warn you guys, in the TI for critical values, inverse what? Inverse T. Because you're dealing with the student distribution, small sample, and this is in relation to your critical value, CV. And we're going to see an example of all that, okay? But also, for the hypothesis test, you don't use z-test, you also use t-what? You're going to use a t-test. Inverse t, t-test. We're going to go over all these details. This is for hypothesis testing about a mean for a small sample. Little bit of notes, little bit of detail. What to do? Let me go back. Where is it? Where is it? Oh yeah, I'm going to remind you guys, like on your test again, you might have said to me, you know, Mr. Judge, can we use the statistics summary sheet on this test? What do you guys think? Yes, that's why I made it. I might add a few more things, but oh, here's some language. You guys know what I mean? At least, less than, more than. So we have worked on some of the language, haven't we? Is the same as, is not the same as. We're going to see some of that, right? So go all the way down to what is this? Oh, here's estimation about a proportion. Here's estimation about a mean large sample. Estimation about a mean small sample, t interval, right? Oh, hypothesis testing about a proportion, inverse norm for critical values. One proportion z-test. Hypothesis testing about a mean for a large sample, inverse norm, z-test. Hypothesis testing about a mean small sample. How do you get the critical values? Inverse t. And then you use the t-test. So as you guys can see, what did I do here for you guys? I created a summary sheet so that you guys can what? Have that as a backup. All right, you guys know what I'm saying? What do you guys think? Is that okay? I don't know. What did my daughter say to me? She said, Dad, I wish I had you for all my classes. Did I know, sweetheart? I know. Said, really, Ashley? Isn't that nice? That's what she said. Whatever. Can't please everybody. Oh, let's go back. And then you say, where are the notes for this? Well, if you're going to get to, where is it? Small samples. Did I already put that in the chat? Because I'm so old, I forgot what I did 2 seconds ago. Do you guys know what I mean? Did I put that already for you guys there? What do you think, Blanca? You still there? I might have put that. Let's see if I did. Oh, I think I did. Hypothesis and mean small sample. Sorry. Doing it again, just like an old man does. Okay. So there's the notes. Now let's see. Let's put this all together so you guys can see it. And we're going to go to the dreaded earthquake question again, because, you know, this is California, and knock on wood, I hope it doesn't happen. But maybe you're into geology. This is hypothesis testing about a mean. Parameter is mu. What's a small sample? Yep. I'm still going to point that out to you guys, okay? So we're going to do the traditional method. So what are they saying? Earthquakes occur at a mean depth of 5. as claimed by the Geology Club at ELAC? I don't know. Maybe that you guys study that in science, right? So what they do here is they go, oh, that means mu what? Equals 5. That's the claim, okay? So maybe that has some meaning. I don't know. Right? You guys okay with this? So when you set up your hypotheses, tell me, where does this go? Where does that go? Do you guys know where that goes? Is that a null or is that an alternate? Why is that a null? Condition of equality. What's the logical opposite of this statement? What is this? Mu what? Mu not equal to 5. By the way, if you're awake, anybody here awake? No. We got to give you guys that on the test, right? The mean sleep time. What is not equal? Two-tailed test. Is that true? All right. We're doing the traditional method. Two-tailed test. Not equal. Okay. So now, what would you guys do? You're going to set this up now, right? Two tails. So what we did last time, what do we say here? Do not what? Then what do we say here? Now, remember, this is all about examples that have small samples, right? So when you read and you take your sample, you say, oh, sample of 25 earthquakes, have a mean depth of 4.6, standard deviation of 0.8. So isn't that the sample size? And they told you it's a mean from a sample, so it's sample mean. And it's a standard deviation from a sample, so that's S. So your sample information, if he said to me, what is that? Well, what was the sample size? 25. What was the sample mean? 4.6. Okay. And then what was the sample standard deviation? 0.8. So you're supposed to use, go back and read it through, right? 5% level of significance. That means our alpha is what? Which is 0.05. Alpha is 5%. Okay, let's do this here, right? So if alpha is 5%, tell me, and there's two tails, how much is in each tail? Okay, is it 2.5%? Isn't this like what you did before? Everything's the same? But notice you need what here? What goes here? What was that called? Critical what? Values. Critical values. You go okay with that? So you guys need critical values. The problem is, this is the what? The t distribution. So to get your critical values, let me go back to this worksheet so you guys can see the summary. Okay? So on this worksheet, yes, in the past, we had to use tables. Oh, my God. I mean, maybe we can still use a table. I don't know. Should I guys show you guys the table? I don't know. Just for fun. Here's what you guys need. Remember I talked about this? If you have the sample size, you need the what? The degree of freedom. What's your degree of freedom? 25 minus 1. What's 25 minus 1? 24? Degree of freedom is 1 less. Didn't we put that in our notes? Okay, so in the old days, we'd have to look for row 24. And I need a smaller highlighter. You say, Mr. Judge, did you have to look for row 24 in the old days? Yeah, I think that's too small, though. Right? We need the degree of freedom. And then what was alpha? You see this alpha being 5%? You got to look for alpha 5% 2 tails. So in the old days, you would look for the 5% with 2 tail column in the old days. So just to kind of share with you guys what you had to do. What's the critical value? 2.064. I don't know. Maybe it's easier in the tables. This is the old days. You go, boy, Mr. Judge. So negative 2.064, positive 2.064. So maybe the tables were the way to go. Those are my critical values. Ladies and gentlemen, I'm going to get rid of that and that. Let's go back to the original size of our highlighter. So you had to find the alpha column, the degree of freedom row, 1 less than the sample size. In the old days for that T distribution, boy. Nice. All right, well, guess what? Your TI does it for you. No table. Although I got to say something about the TI. If I had to program this, I would fire the programmers. Anyway. And you guys are going to see what I'm talking about, okay? All right, you go, what do I do with the TI to get critical values? Well, you got the inverse T function in the variable distribution list. You need to know area to the left of the what? Which critical value? The rightmost. Area to the left of the rightmost. You're going, what? Area to the left of the rightmost. Okay. Area to the left. I know what left is. Where's the rightmost? We're talking about this. Area to the left of that critical value. I know you know what it is. Yeah, so if this tail here is 2.5%, how much is to the left there? Isn't that 97.5%? Isn't that the complement? Area to the left of the rightmost critical value. Maybe that table is easier. You guys see what I mean? Area to the left of the rightmost critical value. So I summarized it all right here. I said, oh, isn't that going to be the area to the left? There it is. Notice my degree of freedom here is 24. 1 less than the sample size because your degree of freedom, that's the definition. Remember we put that in our notes? So it's 25 minus 1, which is 24. So in the TI, that's not the TI. That's the TI. When we go to second distribution, inverse t now. Oh, we already have 0.975. Good. I already have degree of freedom 24. That must be from the other class I did earlier. It is. Paste it. What do you guys get? Yeah, what do you guys see? What do you guys get there for inverse t? Isn't it 2.064? 2.064, is that true? So I'm showing people here in the notes. And so this is why we get the critical values to be positive 2.064, negative 2.064 in our two-tail test by the traditional method, inverse t. Anyway, I think the table was a lot quicker. Yes, that's what the TI has said for inverse t. So you know what I would have done? I don't want to confuse you guys, but I would have put area to the left of the leftmost critical value. You say, why? Because that's how inverse norm works. The default. Isn't that the same as the default for inverse norm? So, God, these programmers, what is the deal with them? Yeah, I know. I kind of just messed everybody up. Inverse norm, the default is area to the left of the critical value. Isn't that right? It's in the notes. Anyway, I'm going to give you guys an option. You're going to see what I'm saying. It's all, again, it's like the devil's in the details, meaning if you want to modernize and use technology, what happens? You start to lose some of the essence of the process and the meaning. And the problem is the people that have done the modernization, how consistent have they been? Programmers aren't necessarily consistent. They don't think like mathematicians. And, you know, and I guess that's philosophical because, go, Mr. Judge, that's coming from you. Come on. You know, look, mathematicians, the essence of math is consistency. That's what makes it different than everything else. It's not inconsistent. That's the beauty of it. But for some people, that's the problem of it. So even in a programming sense, because I'm not saying programming's bad. I'm taking some programming courses this summer. I'm taking Python. I'm going to start to integrate Python in statistics. You're going to say, Mr. Judge, you're a trailblazer. Yes, I am. I'm going to add this to my novel, my book, Python, coding. No wonder I can't sleep at night. I got too many ideas. Too many ideas. Anyway. All right. I forgot my point, but that's okay. What do you do with this information now? Remember, we got to get our test statistic. We're going to use that t-test. But don't forget, you always need this green value. What was mu naught the other day? That mu naught, go back to your hypothesis, okay? Mu naught, go back over here. Wasn't mu naught the what? That was the mean in the null hypothesis. What's my mu naught? 5. So here we go. That's the information you need to put in the TI. Because you're going to use now T what? T-test. Why not Z-test? Z-test was for a large sample. T-test is for a what? Small sample. Is it in your summary? Yes. I would even write it down as you do homework questions. In fact, I'll tell you guys how to be successful in math. You see all the examples we do? I would go back and do them all again on your own. That's what I would do. And you go, what are you talking about? Yeah, after a lecture, what I would do, first of all, I'd rewrite my notes. And then after that lecture, I would actually go over and do all the questions the instructor did. See if I could do them on my own. But if I couldn't, I had the notes on it. I go, oh yeah, okay. This is where I went wrong. I forgot this is the t-test question because it's a small sample. Oh, can't forget that. So I would do that, and I'd write this down just like every single question. Write it down. And then I'd start doing the homework questions. I'm telling you, you're training yourself to get right answers. It's training. And so when I would go to a calculator now, it's automatic because now I would just say, okay, you go to stat, what? Tests. You're going to go now to what? T-test. Yeah, go right ahead.
This is statistics. Hello. So I'm a SI. If you guys don't know what that is, we're the students who take a course alongside you, and then we tutor you afterwards. And we're hiring for next semester for fall and for, I think, summer, mostly for fall. So if anybody would like to apply, it's a really cool job. We have a lot of downtime where you need to study and then you still get paid, essential. But anybody like an application? Yep.
I got a few live ones. Thank you. All right. Okay, so future SI, tell me. T-test.
I don't understand what's happening right now.
Okay. Well, then she may not. Let's give back the application. Is this a hypothesis test about a mean for a small sample? So you hit what? T-test. Okay. Now fill in the what? See all the information we wrote down? You can fill it in. What's mu naught? Well, how do we get it? You go to stat, test, you go to number 2. What's number 2? T-test. T-test. Mu naught. What's mu naught? 5. Didn't we put it in our notes? Sample mean. What was this? 4.6. Sample standard deviation. What's this? 0.8. What's the sample size? 25. Is this a two-tail test? Okay, make sure it's on two tails. Go back if you have to double check. You go, yeah, that's two tails. Okay, this is the classical method. Scroll down now because you're all good to go to hit calculate. Okay, now let me ask you guys this question here. What are you looking for? The t value. Line number 2, what's your t value? Negative 2.5, is that true? What's that called if this is the traditional method? Isn't this going to be the what? That's your test what? Statistic. What is it? Negative 2.5. Is that to the left of your critical value? Or is it to the right of the critical value? It's to the left? Okay, it's to the left. What neighborhood is that in? You're going to reject the what? The null. This is by the classical method. You reject the null. Okay. Goodbye, null. If we reject the null, what are we doing? We're accepting the alternate. What does that mean about the claim? We just rejected the what? The claim. So if we reject the claim, what are we saying? Sample does not support the claim. So what I want to remark to people is these kind of things here. Okay? I did summarize everything here in the notes I wrote for you guys. I summarized it all. I even told you guys here, hey, this is what you enter, T-test. Ooh. It's in your notes. This is what you should see. I even summarized, this is your test statistic. T is negative 2.5. Now, here's what I want to also say to you guys. What about the modern method, the p-value method? Didn't we start the day talking about that? So if I said to you here, let's do the p-value method now. Line 3 is the p-value. Go to the nearest hundredths for a p-value. This is 0.0 what now? 2. Isn't that the p-value? Okay. So what's supposed to happen? If p is less than alpha. What was alpha? 5%. Is that true? So is 0.02 less than the alpha of 0.05? Is that a true statement? Is the 2% less than the what? 5%? That's true. What do we automatically do? Accept the alternate hypothesis. Automatically accept the alternate. Automatically. So you go, okay, I'm going to accept the alternate. Didn't we accept the alternate by the traditional method? We did. And then didn't we say what? The sample does not support the claim? So ladies and gentlemen, you might start to think that maybe that modern method is a lot shorter. You guys with me on this? I'm just throwing it out there. What do you guys think? Not too bad. This is why we did what we did. And so, you know, what I'm going to do here, too, to let you guys know, is we're going to try that here. We're going to try these by the modern method. I do have, and I'll dig up, oh, I got to write notes. What do I got to do? Let me write my notes. Oh, my to-do list. Oh, my God. Whatever. Do you guys know I have to always write a to-do list here? Let me do this in my to-do list. To do. What I have to do is anyway, just some things, some projects I got to make sure. Let's try this one out. This is a hypothesis testing question, ladies and gentlemen, about a mean for a small sample. Okay, because that's what everything is on this sheet. But what are we going to use? We're going to use the what? We're going to use the modern method, the p-value method. So be careful, though. Let's start to read this. What does it say? The mean IQ scores of college professors is what? No more than what? 125. As claimed by the faculty association, whatever, whoever they are. Let's write this down. What parameter is the mean? Mu. What is no more than? What inequality is that? Less than or equal 125. And isn't that the claim? Okay. So you're going to write down mu is less than or equal to 125, and that is your claim. Where does this information belong? Is that a null or is that an alternate? So that belongs in the null position. Is that right? What's the opposite of that statement? Mu is going to be what? Greater than 125. Anybody have any questions on this part? You guys okay with that? Any questions on this part here?
How do you differentiate the null and the other one? Could it be, it's always,
Okay. The null hypothesis always involves a condition of equality. What does that mean? Less than or equal, equal, or greater than or equal? Always, always, what? Always. And then you say, what's the alternate? It does not involve a condition of equality, so it's less than, greater than, or not equal. Now, I'm going to remind you guys of something important here. You see that arrow in the alternate hypothesis? That tells you the test. We need to know that, though. What kind of test is this? Good. You say, well, how do I know that? It's pointing to the what? To the right. Right tail. All right. Now, what do you guys notice about this question, though? There's an issue here. What did they do? They gave you a sample of what? 8 college professor IQ scores. And if I had to write it again, and I got to remind myself, I got a little typo here. I should say a sample of 8 college professor IQ scores are listed below. Jesus, I need an editor too. So the real issue is this: if I'm going to use the modern method, yes, I got the level of significance, which is alpha. Good, I need that. I need a p-value, don't I? Because by this method, I have to compare the p-value to 1%. So I need this p to see if it's less than that alpha, right? So is p less than that 1%? Okay, you okay with that? The problem is I have to run the test. So before I run the test, I know my sample size is 8. I don't know the sample mean, and I don't know the sample standard deviation. You guys okay with that? Does anybody remember, how do I get it? Oh my God, I'm going to have to go back to where? Where is it? I'm going to go to my website, and I have to remind you guys, I wrote a little video, and I wrote a little set of notes in my novel. Ladies and gentlemen, I'll put that in. You guys remember this stuff here? You even had that on your first test? Man, it's back. Okay, what do? Do you guys remember? You're going to have to go to Stat, Edit, Edit. Oh, I'm going to have to go up here and clear out my list. Let's clear that out, okay? Now let's enter all the data. You say, what data? Right here. This is all data they gave you. They gave you 8 data values. So they're going to make you enter this in a list. Okay, no big deal. So what's the first data value? 125. What's the next one? 115. And then 108. And then 143. And then 120. And then 136. And then 112. And then is it 146 or 145? 145. Is that right? Now what do you guys do? You go to stat. Now go scroll to calculate one variable stats. You're already on that one variable stats. Is this in list 1? Yes. Go down to calculate. What are you guys seeing here? Which one is the sample mean? Do you guys know? Is that 125.5? What's the sample standard deviation? If I go out to the tenths, it's 14.3. Is that true? Good. So, ladies and gentlemen, that's what I got to do to get the sample information. But we're not done. Yes, we're going to use the TI. And you say, what do we do with the TI? I already know. I'm going to have to use what? T-test, not Z-test, because this is a small what? Sample. Do you know what mu naught is? Because you always need mu naught. What is mu naught? Yes, it is gonna be. I'm gonna be consistent. See this? It's the value that mu equals, because that's mu is less than or equal. This is mu naught. It's 125. It's the value in the null hypothesis, 125. I need that in my what? TI calculator. Okay. All right. You guys ready? Okay. So you say, how do I get there again? Go to your calculator and go to what? Stat, test. What do I go to? Not Z-test. That was a large sample. We go to T-test. Let's enter. Mu naught. What is that one? 125. Okay. Sample mean. You go, wait a minute, Mr. Judge. I got a little deja vu. Guess what? My sample mean is right there, 125.5. And the sample standard deviation is not the approximation of 14.3. This is a much better approximation. Okay, keep it. So you know what it did? It gave you the information in list 1. You just have to know, is this a two-tail test, left-tail test, or a right-tail test? Go back. This is a what? Isn't that a right-tail test? So in the calculator, what do? You got to scroll down to what? Go to the right. I don't know what you hit, but there's no frequency. Did you hit T-test? Weird. I don't know. Hit now what? Calculate. So let me ask you this question here. Which number is the p-value? Third one. Good. What is that? To the nearest. Go to pennies. Because remember, your alpha's to the hundredth, so compare it to p is going to be point what? Yeah, 0.46. What is this? This is your what? P-value. 46 cents. So I have to check. Is 46 cents less than a penny? Say what? No. What does that mean? You automatically accept what? Be careful. Don't you automatically accept the no? When it's not equal, you accept the no. I'm sorry. When it's not less than, you accept the no. When it's less than, you accept the alternate. So we accept the no. What's the no here? The no is accepted. The alternate is rejected. What do we just accept? The claim. What do we say? Yeah, here's our conclusion. Our conclusion is what? Sample supports the claim. So I want you guys to celebrate the modern method because it does seem to be a bit shorter. Although in this example, yes, we had to enter all the data in. Okay, you guys okay with that? Now you might say to me, but Mr. Judge, I do like the traditional method. Okay, this is t-values again. I show people how to get the critical value. There it is, 2.997. So it's going to be right tail test, 2.998. Your notes are on the traditional method. We entered everything here in that L1. And I reminded people what to do in L1. Don't put frequency anything. Don't put anything in the frequency. Delete it. I don't even know what that means, frequency list. Ask those programmers. Here's your test statistic. Test statistic, well, no, here's the mean variance standard deviation. Okay. We use the test statistic value. Okay, we entered t-test. So I'm doing the traditional method. Your test statistic's 0.099. So, there's a test statistic, and then you can draw your conclusion where it lives on the decision rule. So, 0.099 on your decision rule, if I go all the way back, your test statistic is 0.099. That's close to zero. Do not reject the what? So what does it mean to not reject the no? You are accepting the no, which is exactly what we did by the p-value method. We accepted the what? No. I even wrote it down right here. You accepted the no. So, ladies and gentlemen, this is verifying by the notes. The traditional method matches the p-value method, the modern method. But, they may give you examples where they're nice. You say, what do you mean they're nice? Well, you don't have to enter all the data and find the mean. But even if you did, is it really that big of a deal? Okay, so let's see a nicer version. See how much shorter that might be. Maybe you guys like the p-value method. I'm going to have to give you guys some boring examples. I hate to say that, but some of you guys might be nursing majors. Anybody here a boring nursing major? Sometimes we have them. This is a pulse rate question. Do you guys know who has a higher pulse rate, men or women? Why? Anybody know? I think there's a reason, but I don't know what the reason is. Men have a higher pulse rate, but you can't always believe that kind of information. But anyway, I think generally speaking, the mean is, yes, higher for men. So I might have a pulse rate here, and there might be a lady who has a higher pulse rate than I do. But the mean, the summary, the average, okay? I know this because one of my daughters had a high pulse rate when she was in the womb. And the doctor says, you're going to have a son. I go, really? You're going to have a son. Yay. Is having sons, or any sons in the room? Yeah. Any dads of a son in the room? Are sons great? I wouldn't know. I only have daughters. They're not great? Sons or daughters? Well, well, it's kind of funny. So the doctor tells me, you're gonna have a boy. It's a high pulse rate. Wow, gonna have a boy. And then you know what happened? Took the ultrasound later. Said you're gonna have a girl. Ended up having a daughter. The doctor was wrong. And then later, when I took the daughter to see a doctor again when she was, I don't know how old, I don't know, 2 months, I don't know. The doctor looked in her eyes and she said, oh, your daughter's going to have blue eyes. I said, how do you know? You know what the doctor told me? 30 years of experience. Really? You know what happened? She had brown eyes. I prefer brown eyes. I like brown eyes. But my point is, the doctors can be what? Wrong. This is probabilistic. She should have used language like what? Most likely. Almost certain. You guys see, this is all probabilistic. So you guys are learning something. So why are sons bad? They are the word. You have a brother? Yeah. I don't want to ask. I don't want to ask. How old is you? Is it an older brother or a younger brother? Two younger brothers. How old are they?
19 and 17.
And how old are you if they're younger? 21. You're 21. Oh, let me think about that. Oh man, when I was 21, I was going to carry a rifle when I was 21. Why? Man, actually, I was carrying a rifle when I was 22. Let me double check. I gotta think. I can't think right now. How old was I? Yeah, I mean, I was 22, not 21. I always tell my daughter that. She said, Ashley, you know how old I was when she said she was 22? I was carrying a rifle when I was your age. It's a long story. Did you imagine? You can't even imagine, can you? Good for you. So those brothers are trouble, huh? I don't even want to ask. I don't want to know. I do not want to know. I don't want to know why. I don't want to know. I can only imagine. Are any daughters terrible? They're all good? I hope so. The mean pulse rate of adult males, how about of terrible adult males, is at least, what? 72 beats per minute. This is in honor of those nursing majors, as claimed by the Nursing Association of America. Mew. How do we write at least? Isn't that greater than or equal to 72? And that is my what? Claim. Isn't it 72 or more? Okay. Where does that belong, ladies and gentlemen? Does that have a condition of equality? Yes. Put that in the null hypothesis space. And then, what's the opposite of that? Mu is less than 72. You guys okay with that? All right. Everybody okay with this so far? So far, so good? Now, what I do because I already know what's going to happen in my TI. I got to know if it's a left tail, right tail, two-tail test in the TI. I already know. So I already look at that alternate hypothesis and I notate this is a what? A left tail test. I already know. I keep that in mind. Okay, now what do? We're going to go read. Okay, what does it say? Sample of 25 adult males reveal a mean post rate of what? And a standard deviation of 6.6. That's all my sample information. Would you guys agree with that? So what I write down now is this. I say, okay, my sample information is what? Sample size equals 25. Sample mean equals what? 75.5. Sample standard deviation is what? 6.6. Now, don't ever forget what also goes in your calculator is what? See how I bring out the green? What value is this? What is that? You guys remember? U naught is what? What do you guys use? The TI calculator T test. Why T test? Small sample. Every one of these examples I give you on this sheet are small. It's why I separate it, small sample. You guys know what I mean? Okay, let's get out the TI. You guys ready for the TI now? Looks like we have all the information just staring at us right here. You guys know what I mean? It's right there. You guys ready? Here we go. Stat test. Don't go to Z test. Where do you go? T test. Okay? So what is that mu naught? And what's my sample mean? 75 point what? 5. Sample standard deviation is going to be what? Sample size is what? What kind of test is this? Is that a left tail? Hit enter. Go down to calculate. So, okay, what's your p-value? You guys remember which one the p-value is? We're going to approximate that to the hundredths. That's going to be point what? 0.99. Isn't that the third number? Okay. So there's your p-value. Well, what do we have to check? Yeah, is that number less than the level of significance called alpha? Isn't 10% 10 pennies? So let's go. Or 10 cents. It's P less than alpha. We get what? 99 less than what's alpha? 10. So we're going to have to check, is that p-value smaller than 10%? What do you guys know? Is that true? Nope. If it were true, we accept the alternate. When it's false, accept the what? The null. Okay, you guys see that there? Accept the null. Now, if we're accepting the null, we're getting rid of the alternate. What does the null happen to be? The claim. So what's our conclusion going to be? Sample supports the claim. You say, why does the sample support the claim? Because aren't we embracing the claim? Aren't we circling the claim? So the sample is suggesting that, yeah, the mean pulse rate is at least 72 beats per minute. That's what the sample is suggesting. So by the modern method, ladies and gentlemen, this is what we do here. And of course, if you want to see the traditional method, well, you have the table there and you have your inverse T information to get your critical values, and then you have your left tail test with its critical value, and then you have the t-test information that gives you your test statistic, and that's 2.65, all 2.652 if you go to the thousandths, and it's summarized there. So you can look over the notes and you can do what? You can verify. Whew. Maybe on your test I should give you the mean lifespan of Hawaiian residents. Oh my God. Because you guys know, I believe, if I'm correct, I believe people who live in Hawaii outlive everyone else in America. I believe that's the case. I got to double check. I did write a statistics manual book on all this stuff, believe it or not. It's called Statistics and Social Justice. Anyway, interesting. It's out there. And I think I looked at lifespans by state. And I have it. And if I kind of think from memory, I can't remember where I got that from, but it's somewhere out in the Canvas cyber. It's actually, I can try to dig it up, but whatever. I was a part of a team that did that, and but I remember doing that chore. Yes.
The question I have is for the lifespan. Starting from what age will you prolong? Because people born there, they will prolong their life, but then if you start out at a certain age, does it still prolong because you're living in that country?
No, you have a very good point, and I got to make if I understand your question the way you're saying it, you have a point. It's kind of like this. About maybe 6 or 8 years ago, I'm trying to remember, there was a report that came out about lifespan in California, and the report was what ethnicity had the longest lifespan. Okay, you guys okay with that? And it was it came out that Hispanics, that ethnicity, I can't remember if it was Hispanic American or just Hispanic in America, how they described it, had the longest lifespan. And I reported it to my class because I listened to it on the radio or something. And of course, my students were like, "Yay!" They go, "Great." And it's related to your question. You see, if you thought about it, what has to happen to get a lifespan? You have to die. So what happens is when people die, they ask them, "Hey, how old were you?" And they go, "Okay, 92. You guys know what I mean? They gather that data to get the mean lifespan from a sample. So you have to die. Now, if you thought about it, for those students, who was dying? Probably their grandparents or maybe great-grandparents. Now, on the Hispanic side of my family, my Irish father died at 59. Heartbreaking, ladies and gentlemen. I'm still haven't gotten over it. He died at 59. On the Latin side, my grandfather, the Mexican side, he lived to 94. So what I suggested to the students, I said, "Hey, wait a minute. It's really your question. You have to die. What are your grandparents and great grandparents doing? How do they live? What are they eating?" I know what my grandfather and my grandmother ate. They ate a bunch of whole foods. They ate whole foods. You say, what are they eating? Well, they ate eggs. They ate cactus. They ate beans. Do you guys know what I mean? Whole foods. And what else were they doing? My grandfather never knew an easy day in his life. You know how he relaxed? He went outside and pulled weeds for hours in the yard. He did yard work. You know how hard that is to bend over and pull weeds in the sun? Never knew an easy day in his life. That's how he relaxed. Lived in 94. My grandmother lived in 92. I don't think she ever relaxed. She never stopped moving. So you say, well, what's your point? Well, I asked the students in that class, what are you guys having for lunch? Chili cheese fries with pastrami with a side of ranch at the Hat. So the point of your question is just exactly that. It might be for that group of people, yes, they're outliving everyone else. However, if you ask young people today, what are they eating and what are they doing? They're probably sedentary and they're not eating like they should. They're certainly not eating or living like their grandparents. So because of that, these numbers are going to change. Unless there's some medical innovations that come along that prolong your life, and there could be. If you're living differently than your parents or your grandparents, and it's not in a positive way, then yeah, that data is going to change. You see what I mean? What's for dinner? What are you going to have for dinner? Pizza. Domino's. Huh? Beans and eggs. Exactly. Is that right? Do you guys know what I'm talking about? Cactus, beans, and eggs. And my grandfather had, what did he have for breakfast? He ate those shredded wheat. He had shredded wheat. You guys know it doesn't have any sugar. It's all wheat. I think it's called shredded wheat and milk. There's no taste in that, no flavor. That was his breakfast. Wow. He puts me to shame. Puts me to shame. Isn't that horrible? You guys ever had shredded wheat? Yeah. Every morning, shredded wheat. Like, Grandpa, what do you have? Toast and shredded wheat. Like, ooh. Yeah, I better get on the shredded wheat diet. The mean what? Lifespan of California residents is what? 77.8 years. As claimed by who? By the state of California. What do I do? Isn't that equal? And that's the what? Blank. So where does that go, ladies and gentlemen? Where does that belong? That's a null hypothesis. Is that right? What's the logical opposite of that statement? Not equal. What does that tell me? Yes. So emphasize that. This is what? It's a two-tailed test. So far, so good? We're going to use the modern method, ladies and gentlemen. Now, take your sample here, okay? Because if we read further, we're going to read, it says what? Where does it say? Okay, somewhere, okay. It says a sample of 20 college students. That means sample size is 20. Has a mean lifespan of what? 76.2 with a standard deviation 9.8. So write this down. What's your sample size? N is 20. What's the sample mean? 76.2. What's your sample standard deviation? Isn't that 9.8? Okay. Now remember, they want us to use the what? 1% level of significance. So your alpha is 1%, which will be 0.01. You guys are almost there. Okay. So we're going to have to, as we use the modern method, we're going to check, is that p-value less than the level of significance? Is it less than 1%? But in order to get that p-value, we got to enter the sample information in the TI. What do you guys need? We need one more piece of information. Anybody know? What do I need? What's missing? What is it? What's missing? Mu naught. Where do you find mu naught? It's the mean in the null what? Hypothesis. So mu naught is 77 point what? 8. So in your TI, like I said, if I were you guys, as you do your questions, put t-test, because this will help you, try to remember what you're doing. Because on a test, you might feel a little nervous, a little stressed, but if you're kind of following a procedure that you normally do, then it alleviates the what? You're not thinking of the stress. You're not stressed. You're kind of following this procedure that you go through. But you have to go through a procedure. One of the worst things to do on a test is have to sit there and think and not know what to do. I rather just act. So I kind of read through it the same way I'm showing you guys. I go through my questions the same way. I might even highlight and use the same exact colors. Have you seen the consistency with my colors even? Exactly. It's not an OCD thing. It's not OCD. It's about organizing the data and the information in your brain. And you have to go through it over and over again to let it, it's kind of like paint. If you have to paint so it's there, you got to do multiple layers. Anyway. Sports. Don't you have to practice in sports? What happens if you don't practice? Anybody know? Do you do well in sports if you don't practice? I don't think so. I wonder if Mookie Betts practices. What do you think? T-test? I wonder if Kershaw practices. Should we ask Kershaw? Hey, Kershaw, do you practice? Mookie, do you practice? Mookie Betts? Okay, what was mu naught? 77.8. Okay, what's the sample mean? 76.2. What's the sample standard deviation? 9.8. What's your sample size? 20. Hey, was this, what kind of test was this? You got to go back and you got to look, double check. This is a what? Is that a two-tailed test? Okay. So make sure you put your calculator on the two-tail. Enter. Scroll down and hit calculate. What is the test statistic value? I'm sorry, your p-value. To the nearest, what? Hundredths. 0.4 what? 7. Because remember, you're going to compare it to the alpha value, which is to the hundredths. So my p-value is 0.47. Okay. So we're going to check. Oops. Is that p-value, is 47 cents less than a penny? Say what? No. What does that mean? Accept the no. It means you accept the no. Okay, no, you're accepted and the alternate is gone. We just happen to accept the claim. Is that true? We happen to accept the claim, so the sample supports the claim. So, ladies and gentlemen, the sample supports the claim, and the claim is that, the mean age is 77.8. So, if you want to see the traditional method, here's your table for alpha. Okay. This gives you your critical values. And it's a two-tailed test with the critical values. This tells you how to get your test statistic. And the test statistic in this case is going to be negative 0.73. Okay. And that's what we got. And, I don't do insomnia. Sorry. If I have insomnia, I'm not going to do that. You guys can try it if you like. Should we do one more for the road? Yay or nay? Let's try it out. Should we do it fast? The mean number of college students who take a remote class is not. What is this not? What's that inequality? It's not equal to what? 12. As what? As claimed by campus researchers. So, not 12. Where does that belong? It's an alternate hypothesis. Is that right? No condition of equality. The opposite of not equal will be equal. And don't forget to put the phrase claim. Ooh. Okay? Don't forget claim. So notice. Sample of 15 college students reveal a mean of 10.5. Standard deviation 2.3. Let's do the sample. Okay? Don't forget, not equal means what? Two-tailed test. Green, what are we looking for? You not. All of this information is in the TI under what? Under what? Under t-test. Is that right? We're going to check, is the p-value less than the level of significance? But what's the level of significance? Alpha is what? 10%. Look at that, ladies and gentlemen. So is the p-value going to be less than 10%? We're going to find that out. Okay? How do you find it out again? Stat, test. What's the essence of today? T what? Test. All right. Mu naught. 12. Sample mean. 10.5. What's the sample standard deviation? Sample size. What kind of test is this? Two-tail. Is that right? All right. Now let's see. What's our p-value, ladies and gentlemen? P-value is point what? 0.02. So we have to know. Is 0.2 right in here? Is 2 cents less than a dime? It sure is. What do we do then? Accept the what? Alternate hypothesis. That's the p-value method. If I get my p-value and it's smaller than the level of significance, we accept the alternate hypothesis. So what's the alternate hypothesis? Happens to be the claim. So what's your formal conclusion? The sample supports the claim. So ladies and gentlemen, I'm going to share with you guys something in case you didn't know. Okay. Sample supports the claim. So in case you didn't know, what I did in Canvas, you're in your class here. In fact, if you scroll all the way down here to the Test 4 study guide, did you guys know there's already a study guide in Test 4 for you guys? You may not know. You go, Mr. Judge, did you get that up? Yeah, I did. I'm actually going to edit it just to let you guys know. Let me share with you guys what I'm talking about. So take a look at this. This is the stuff we did on estimation. Take a look at your assignment section. You have to do like 1 to 18 all on estimation, I think. I'll double check. But notice this. For some of these hypothesis tests, I say use the traditional method. Traditional method. And then I go down and I say use the eventually. Oh, the modern method, the p-value method. And what kind of questions do I ask, right? By traditional method, what do you guys notice? You say things like what? Hey, what is the claim? What's the null hypothesis? What's the alternate hypothesis? What are the critical values? What's your test statistic and what's your conclusion? Aren't those things what we've been talking about? Those are your answers now. And also, if you said, well, what happens with the p-value? I'm asking you the same questions here, right? What's the claim? What's the null hypothesis? What's the alternate hypothesis? What's the p-value? What's the relationship between the p-value and the level of significance? P is less than alpha or P is not less than alpha. And then what is your conclusion? So I'm asking you all the little piece of information that we've talked about. Now, I'm going to edit this. You say, why am I going to edit? Because I'm going to ask an additional question. I told the other class this too. What I'm going to ask is this a two-tail test, left-tail test, right-tail test? So you say, why? Because those questions help you enter information in your calculator. So it's almost like directing you to the right answers. Does that make any sense? So I'm going to add that to those questions. And of course, you always look at the alternate hypothesis inequality. Then you know if it's a two-tail, a left tail, and right tail. When is it two-tail? Not equal. When is it a left tail? Alternate hypothesis inequality points to the left. When is it a right tail? It's pointing to the right. All the stuff we've talked about and went through for the last like 3 days even or more. But I'm gonna like I said, I'm gonna add those kind of questions, not to make it harder, but to have people be directed to how to get the flow of what you do things. And of course your test is gonna be shorter than this. It's not gonna be as long. But as you guys can see, is this impossible to do? What do you guys think? Is that impossible? I hope not. Also, double check. Some questions have come up. If I go to the assignment section. Man, this is so slow. Come on. Homework 4. You have statistics lecture 13, 1 to 18 all, but also in that 1 to 18, I'm having people watch the video on estimate the sample size. Remember I gave you guys an extra credit assignment to do that? Hopefully you did. All you got to do is plug in numbers. So if you said, how do I do that? Well, you can watch this. You plug in the values. And there you guys go. And then, oh, I'm going to have to edit this. You can't do statistics. You can't do all of these. Is this you guys? You guys are the afternoon class? So I think if I go back to here, is it 1 to, where did I put? Let me double check. I got to double check your homework. Oh, no, you can't. You can't do them all. See, I'm glad I'm double checking. You guys are going to lose your mind. You know why I'm double checking? Because we haven't talked about comparing two what? Parameters. That's why. So it's actually 1 to, yeah, it's 1 to like 14. So I don't want you guys to lose your mind there because we haven't compared two parameters. Okay, two means, two proportions. You want to know if they're equal or not equal. Anyway, we're... Okay, so that's now really up to date. So there you go, folks. Sorry for taking some extra time. I apologize, and I'll see you guys when? On Monday.